Welcome back to another exciting pre-class video. This time we're going to be talking about SOHCAHTOA. So far, all of the trig functions that we've used have been defined in terms of different physical properties of the unit circle. Now, if we have a larger circle, we can still find some useful information about our trig function. Let's say we've got two different size circles. There's a unit circle that we can see by the fact that it has a radius of 1. And then we've got a larger circle with an unknown radius called r. It doesn't matter how big this is. It can be 2 or 3 or 1.5 or even smaller than 1. And as usual, we've got an angle alpha that intersects our unit circle at some point x and y, and it intersects our larger circle at another point. Let's call this x1 and y1. Now we'll notice that in terms of the unit circle, sine is just the y coordinate and cosine is just the x coordinate. And that for our larger circle, we still have a y coordinate with height y1, and we still have an x coordinate with width x1, and we can actually use this information in order to help us out. Specifically, on our unit circle, we've always defined sine of our angle as just the y coordinate. If we look at our larger circle instead, we're only given x1 and y1, and so we can write y1 divided by r. We'll notice that if our radius of this circle is 1, then our formula simplifies to sine of alpha is just y1. Similarly for cosine, we normally write cosine of alpha equals x, but we don't know x. We only know x1 if we're given the x and y coordinates on our larger circle, so we can write x1 divided by r. The reason we can do this is this smaller triangle and this larger triangle have the exact same angles, and therefore they're what are called similar triangles. They're both right triangles that have an angle alpha in them. And so this ratio, y1 divided by r, that will equal just y. And x1 divided by r, that will equal just x. We can see this even further with our other trig function, tangent alpha. It doesn't matter what size circle we're using, we can define this as sine of alpha divided by cosine of alpha. There we go. For our unit circle, we could define this as y over x, but for our larger circle, we could define this as y1 over r divided by x1 over r. And if we clean this up, we'll see that this actually equals y1 over x1. And because this is just the ratio of the height to the width of our right triangle, this also equals y over x. And so what this tells us is that the size of the circle doesn't actually matter here.